Let's go to the example for kinematics. A particle P starts from a point A and moves along a horizontal straight line. Its velocity after t seconds is given by this piecewise function. The following diagram shows the graph of V. Find the initial velocity of P. When we talk about initial velocity means V of 0. So we substitute 0 into this equation. You will get -2 times 0 plus 2 equals 2 centimeter over second. For B, P is at rest when t equals 1 and t equals P. Find the value of P. Basically, we just need to figure out the zeros of the function, this one. So I will show you a graphing calculator.
Now I put these two functions into a graphing calculator. I don't want to graph y1, so unhighlight this y1. Go to graph. I need to change the window as x will be from 0 to 12. And y, it doesn't matter, so graph again. You could say this is the graph we got. We want to figure out this 0. So we do second trace 0. Left bound, I can put 2. Enter. Right bound, let me do 7. Enter. So this will be the solution. X equals 5.22.
We got the P equals 5.22 seconds. Let's go to 4C. When t equals q, the acceleration of P is 0. Acceleration, that means the derivative of velocity. When derivative of velocity equals 0, which means it's the minimum point here. This will be the q. So I will show you on the graphing calculator.
Since we are looking for the minimum point, we will go to second trace 3. The minimum point is around here. Left bound, we need a point on the left side of the minimum point. So let's use 0.5. The right bound, we can use this 3 because 3 is on the right side of the minimum point. Then enter. So that you got the minimum point is 1.95 or negative 1.76.
So we get the q equals 1.95 seconds. According to the graphing calculator, this coordinate is 1.95, negative 1.76. Since we are looking for the speed means you have to give the positive answer. Therefore, it will be 1.76 centimeter per second. Go to 4D. Find the total distance traveled by P between 1 and P. This is P. We will use a graphing calculator.
So we will use the formula for distance here. Y2 is the equation we got to use. So go to Math 9. From 1 to 5.22. Math, number, absolute value. Alpha trace go to y2. Then here is dx, enter. Your answer will be 4.45.
So you get the distance is 4.45 centimeters. Hence, or otherwise, find the displacement of P from A when T equals P. I will show you on the graphing calculator. From A basically means when T equals 0.
Now we will go to Math 9. From 0 to 1. Alpha trace, this is a y1. Then go here is a dx. Then plus Math 9. From 1 to 5.22. Alpha trace go to y2. Then dx. Enter. Your answer will be negative 3.45. Remember, when we try to find the displacement, there is no absolute value. When we put the absolute value, means we are looking for the distance.
So the displacement equals negative 3.45 centimeter. Let's go to 7a. A particle moves along a straight line such that its velocity meter per second is given by v of t equals this for t greater than equal to 0. On the grid below, sketch the graph of v for t from 0 to 4. When you draw a graph, you have to make sure you have 5 key terms. That's the x-intercept, y-intercept, minimum, maximum, and asymptote line, if there is. For this equation, you do have an asymptote line. That will be y equals 0. This x-axis is asymptote line. Second one, you have to make sure your graph is a smooth curve with correct shapes. And also for HL level, you have to make sure you have a correct starting and ending points in the correct window. Most of the time in HL level, they give you the correct window. In other words, the coordinate plane was set up for you. So we will use graphing calculator to figure this out.
After we put the function into graphing calculator, you need to change the window. The same as the given window in the problem. So you get the -1 to 4. -1 to 3. Then you go to graph. We need to figure out this maximum point. So do second trace 4. The left bound, let's go to 0. Right bound, we know this is a 0, 1, 2. Let's make a 2. Enter, enter. So you get the maximum value is 0.588, 2.16.
From graphing calculator, you could say the maximum point is 0.588, 2.16. I label here. The starting point is 0, 0. Ending point will be asymptote line. Therefore, I will sketch the graph like this. Make sure do not cross the asymptote line. For 7b, find the distance traveled by the particle in the first 3 seconds. I will show you in the graphing calculator.
Okay, so we go to Math 9 from 0 to 3. Since we are looking for distance, don't forget absolute value. Alpha trace, find y1. Then go here, dx. Enter. Your answer will be 3.33.
So you get 3.33 meters. For 7c, find the velocity of the particle when its acceleration is 0. We already got here. Acceleration equal to 0, basically we are looking for the maximum point. So the speed will be 2.16 meter per second.